So now let's go to another important concept in the theory of constraints is how the flow of information happen. Okay, how do I send information and how the system works after you start production. Okay, so that's called a drum rope buffer rope system. And we're going to see an example here so you guys can understand. There's a definition there. You can read it later. Okay, so let's say that I have process A here, capacity of 800 units. I have process B with a capacity of 500 units, process C with capacity of 700, and the market demand is 650 units per week, right? So first question is always which process or which step is going to be the bottleneck. So remember, there's a tricky caveat to that question, right? So if it's showing capacity, it's the highest. If it showing sorry. So remember, there is a tricky thing on this question, right? Because if it's showing the capacity, I have to look at the lowest capacity. If it's showing the time that it takes for a product to go over that process, then I have to look at the highest number. So keep that in mind. And then some problems can have both information in the same problem. And then you have to figure out how to put it all in the same unit of analysis. So capacity 800, 500, 700, 650. I have to look at the lowest number. So capacity of B is 500 units. So here's my bottleneck. What does that mean? Well, imagine that I'm producing here at 800 a week all the time, right? So I'm going to produce 800, and this process will use only 500. So very simple math. How many will be here every week? 300 more. So every week, you're going to grow this inventory by 300, 300, 300. So 3, 6, 9, 1200, 15, blah, blah, blah. And here, process C is only going to produce 500, but that's what's coming, and market demand is always going to buy 500 because that's what is coming, right? And, well, what should I do then? Should I keep producing, for weeks and weeks and weeks, and this inventory is going to grow, 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 but I don't need that inventory here? No, you should not, right? And, the concept here first is, okay, we know that this is the bottleneck. The other ones are not bottlenecks. Is you have to have an inventory here to make sure process B doesn't stop, because if you lose time on process B, you're going to lose the production of the whole system. So you have to keep some buffer here, but it doesn't have to be that big because process A is very fast and it can recover it pretty quick, right? So you're going to produce, 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 and you're going to say, let's say that we establish a rule: when I get to 900, I stop. Right? And then this will send an information to stop, and then process A can stop, and process B can, keep going. So in 1 week and a half, it will go back to from 900 to 750. And then when say, okay, when it gets to 250, I need to start process A again. So then you send the information, which is the rope, to release more material so process A can start producing again. And when process A starts, that is going to be a lot because it's 800 a week, so it's going to increase, increase, increase. So that's what we call the drum buffer rope. Question. We know that the rope is that information. We know that the buffer is here. Who is the drum? The drum comes from the concept of, the pace, the rhythm, right? And it's the boom, 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 boom that gives the pace of process of the whole system, right? And the process that gives the pace for the whole system is going to be process B, right? So process B is going to be the drum. You have the buffer here, and you have the rope. Okay, and that's called drum buffer rope system because it's basically manage the inventory so you don't have too much inventory here in the middle.